Hello, and welcome to this end-to-end demo showcasing how you can connect your application to a microservice while running inner loop development cycle with Odoo. Now, what is an inner loop development cycle? It simply is the initial phase of your application development cycle where you are continuously coding, building, and testing your application locally until you are ready to move it to staging or production. So for this demo, we take example of a developer who's working on an application that requires connecting to a database. This application, once it is ready for production, will be deployed in a cloud native environment like Kubernetes or OpenShift. And for this reason, the developer would like to run their inner loop in a production-like environment, but finds it difficult to do so because of the complexities and steep learning curve involved in running an application in such an environment. To top it off, they also have to deal with the database. This is where Odoo comes into picture. With the help of Odoo, dev file and the service binding operator, the developer can connect to a database and run their application on the cluster with two or three simple commands. Before we begin with our demo, we'll need to install the Odoo binary. Installation instruction for all the standard operating system is available on the odoo.dev website. I already have installed Odoo, so I am going to skip this step. Here, I have a very simple Go project with me. Let's quickly take a look at it before we move on. So this Go application will connect to a MongoDB database and then ping it. We are using a MongoDB driver. Uh, it expects the environment variable to provide it with the connection information. Um, Now, I also have a dev file with me. So dev file, it is an open standard definition for defining your development environment as a code. Odoo uses the dev file to understand the resources that it should create and the commands that it should run to set up a development environment for you on a cluster. Since we're going to work in a cloud native environment, our applications will essentially run inside a container. And for this reason, we are defining a very simple container component over here. It will use the Golang image provided by DevFile. We're also defining a bunch of other information over here. Then we have defined commands. There is command to build the application and then to uh, run the application. There's also information like metadata, schema version, starter project about the dev file, but we don't need to bother with that right now. Um, okay, so for this demo, I am going to use a local minikube cluster. I have already spun it up, so we'll quickly check its status, make sure it's running, which it is. We'll now create a namespace, and this is where all of our resources will be created. Uh, since we require to connect our application to a database, we are going to deploy this database as a microservice. It will be an operator-backed service, so we'll need to install an appropriate operator for it. For this use case, I am going to use the Percona distribution for MongoDB operator. I have already installed this operator, and by following instructions on this page, I've also deployed a very simple Percona server MongoDB service by following this particular example. Now, we will be using Odoo add binding command to bind our application to this MongoDB microservice. And for this, Odoo relies on the service binding operator to provide it with a list of all the bindable services that are present on the cluster. I've also already installed the service binding operator by following this instruction that is available. Um, so let's quickly take a look at these operators, make sure that they're installed. We see Percona server MongoDB and service binding operator. We'll take a look at the PSMDB. We see that a MongoDB instance is running inside this particular namespace. So this namespace is different from what we created earlier. This is because the Percona server MongoDB operator is namespace scoped, and that is why all the services that we create related to it will be accessible from this particular namespace only. But that's not going to be a problem for us. So now let's run Odoo dev to run our application on the cluster. We'll wait for Odo to create all the necessary Kubernetes resources, sync the files into the container, and build our application on the container. We see that our application is ready. So we'll try to curl the URL that we have. We see that it failed to connect to a server because it wasn't able to obtain URI information, which is expected because we haven't connected to database yet. So that is what we're going to do now. We'll run the odo add binding command. We'll select a list of service which is not in the current namespace. So we'll go to all the accessible namespace, select the desired namespace. We have MongoDB instance, which is correct. We'll use the default name. We'll need to bind as environment variables because that is what our application expects. So we'll bind this information as environment variable. We'll use the default naming strategy. And this ODOID binding command will add a service binding Kubernetes resource to our dev file. Now, Odo, as soon as it detects changes in the dev file.yaml, it will create the service binding resource on the cluster and uh, recreate all the resources and then resync the changes and rebuild our application. We'll wait for it to do that. It looks like we are ready to try again. So, okay, sorry about that. I'm going to hit the curl command again, and we see that it successfully pinged the server. So that's well and good. We have successfully connected our application and database microservice. So there's also Odo list binding command that you can take a look at. It will list all the bindings that are currently present on your cluster. In this case, we only have one. You can also run Odo describe binding from your component directory to obtain information about the binding. So this is available binding information that has been exposed to your application. Now that I'm satisfied with what we have, I'm going to hit Control C and let Odo delete all the resources that it had previously created. I can also run Odo remove binding with the name of the binding and remove the resource from my dev file. So when I do this, it will remove the service binding from my dev file. So that's all for this demo. As I said before, Odo is a simple command line tool that can help you run your inner loop development cycle in a fast and iterative manner in a cloud native environment by abstracting away all the complexities of it and letting you focus on what is important to you, which is your code. You can also visit audio.dev website and follow our quick start guide to get a hands-on on Odo. That's all for today's demo. Thank you very much.